Good afternoon, class. We are looking at Module 3 that covers Chapters 5, 6, and 7. Chapter 5, Trigonometric Functions. Chapter 6, Periodic Functions. Chapter 7, Trigonometric Equations and Identities, also known as Analytic Geometry. So here's Chapters 5 and 6, Trigonometric Functions and Periodic Functions. Answer the following. Convert 315 degrees to radians. Well, first I want to remind you that we have the relationship that pi is equal to 180 degrees. Therefore, d standing for the degrees over 180 equals r standing for the radian over pi. You can do the cross product, and also let me just show you the cross product here. So if you do the cross product, (180) times r is d times pi. So if you want to, for example, solve for d, which is degrees, you can divide both sides by pi, or divide both sides by 180 to get to r. So if I want to get to r, different color, I divide by 180 as an example. Just so in essence, you can say multiplied by pi over 180. Here's the degrees. Simplification will result in 7 pi over 4. I mean, just for the sake of argument, both of them, you can see that they are divisible by number 9, because 3 plus 1 plus 5 is 9. 180 is divisible by 9. I take it from there. If you divide by 9, then you can divide also by 5. Both of them are divisible by 5, and you get 7 pi over. Anyways, to convert from radians to degree, you can multiply by the reciprocal of this one, which is 180 over pi, or as I mentioned, you can put it here. So if you were to put it here, I would just want to make a point of that too. You would say d, so let's put 180 here, pi here, and let's put d, which is 315 degrees here, and r, which is missing. You can do it that way. Either way makes no difference. So these two, of course, the pi's cancel each other, and 180 is divisible by 5. 36. 9 times 36 gives you 324 degrees. Convert 3 radians to degrees. Now, it's 540 divided by pi. This is an exact answer, everybody. However, you can change it to 171.89 degrees because you want it. Perhaps they will ask you how many decimals. Normally, we don't go more than 2 decimals for degrees. What about 14 pi over 3? We want sine of 14 pi over 3. What should we do? Every trigonometric function is a periodic function with the period of 2 pi, except tangent and therefore cotangent, where the period is pi. So a periodic function repeats its value at regular intervals. Trig functions are periodic. K is an integer. So sine of theta plus 2k pi is sine theta. Cosine would be the same thing, 2k pi. Secant and cosecant go with that. Tangent is just pi, so plus k pi. So all you have to do, because this is sine, take off multiples of 2 pi or add to it, depending upon whether it's negative or positive. This is larger than 2 pi because remember, since the denominator is 3, this is 6 pi over 3. Therefore, 14 pi over 3 is larger than that. If 6 pi over 3 is 1 complete revolution or 2 pi, then 12 pi over 3 is 2 of that, and that is the sum of 12 pi divided by 3 and 2 pi over 3. So the answer is 2 pi over 3. So sine of 2 pi over 3, and that's square root of 3 over 2. So let's just write this as sine 2 pi over 3. 2 pi over 3 is 120 degrees. And we are going to discuss the reference arc. The reference arc is pi over 3. Sine is positive in the first as well as the second quadrant. So that's what we have. We are going to move on. I'm going to answer the following questions. Name the quadrant that contains the terminal point of the arc t equals 2. Justify your answer. Reminding everyone that this is a unit circle, x squared plus y squared equals 1. This is the positive side, counterclockwise. This is the negative side. Location 1, 0. The angle that the arc makes with the positive side of the x-axis is the angle of interest. So this is 0 degrees, this is 90 degrees or pi over 2. This is 180 if you go a complete, it's a straight angle, everybody, this one, which is half of revolution. That is theta equals pi or 180 degrees. If you end up here, it's 270 degrees or 3 pi over 2. A complete revolution brings you back to 0 or 2 pi or 360 degrees. So this is 90 degrees, 180 degrees. 270 degrees. Okay, so as I was mentioning, unit circle, x squared plus y squared equals 1. Sine is represented by the y coordinate. Cosine is represented by x coordinate. Every point has coordinates x comma y. And tangent by definition is the ratio of sine over cosine, which makes it y over x. So tangent is y over x or sine over cosine. Cotangent is the reciprocal of that, x over y or cosine over sine or 1 over tangent. Cosecant is 1 over y or 1 over sine. Secant is 1 over x or 1 over cosine. So let me add this one is 1 over cotangent t. This one is 1 over tangent. So these are various identities that we should be comfortable with. So a quick recap, unit circle, x squared plus y squared equals 1. Sine, when you have a pair x comma y, sine t represents the y and cosine represents the x. So pi over 2 or 90 degrees is about 1.57. Just remember pi is roughly, this is not exact, is 3.14. So half of it is 1.57. And 3 pi over 2 or 270 degrees is about 4.71. And 2 pi is 6.28 roughly. Now we are ready to answer the question t equals 2. So t equals 2 is between these two numbers. So here t is between 0 and 1.57. Here between 1.7 and 3.14. Here between 3.14 and 4.7. And finally the fourth quadrant. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, just like a basic graph, a grid. And in this case is between 4.71 and 6.28. And we want t equals 2. Where does it fit? It fits between these two. So the answer is quadrant 2. Just wanted to make sure that it is explained with details. Find the exact value of cosecant of 11 pi over 2. So to answer that, I'm repeating what we had in the previous page, and we decided t equals 2 gives us the second quadrant and y. Now I want to discuss the reference arc or reference angle. Standard angle is theta, reference arc is theta prime, and depending on the text, everybody, they may say theta sub r. Okay. So theta sub r, that's another way of saying theta prime or the reference angle. All right. I've seen theta tilde also, but in any way. Now, obviously, what is the reference arc? If the angle belongs to the first quadrant, they are equal. The reference arc and theta are identical. If it's not, what happens? Reference arc, by definition, is the smallest angle that the terminal side makes with the x-axis. And it doesn't say about the positive or negative, okay? Just the closest possible way of drawing it. So with that being the case, in this case makes no difference. But if you're in the second quadrant, it is closest to the negative side of the x-axis. This becomes your reference arc. So let me erase my word. So in this case, they are identical. In this case, pi minus theta becomes the reference arc. In this case, this is your reference arc. So the arc theta minus pi. And if it's in the fourth quadrant, this is your reference arc, the red one, right? So that means 2 pi minus theta. And I hope it makes sense to everybody. So here's the reference arc. This is another picture. So I want you to be exposed to both of them and see which one is clearer. This would be the reference arc in the first quadrant. They are identical. This would be the reference arc in the second quadrant, which results in pi minus theta. This would be the reference arc. So that's why it becomes theta minus pi. Take a look. And in this case, this one is the reference arc, and that's why it's 2 pi minus theta. So because this is larger than 2 pi, remember 2 pi is 4 pi over 2. Let me just write that. Why am I writing 4 pi over 2? Because this has the denominator 2. So I'm going to write 2 pi is the same as 4 pi over 2. So I can take 4 pi over 2 or multiples of that. For that matter, I can take out 8 pi over 2. So it's the sum of 8 pi over 2 and what? 3 pi over 2. So this is the same as cosecant of 3 pi over 2. And cosecant is 1 over sine. So it's 1 over sine of 3 pi over 2. And 3 pi over 2, the reference arc is pi over 2. Sine of pi over 2 is positive. Sine of negative pi over 2 or 3 pi over 2 is negative 1. So 1 over negative 1 is negative 1. It's one of those common arcs. We are supposed to know the answer. Okay, everybody? It's one of the common arcs. So we have the reference arc, and then there are common arcs that you should be comfortable with trigonometric functions. I am going to write some of them, of course. We have the quadrantal angles that are 0 degrees. Ninety degrees, 180 degrees, 270 degrees, 360 degrees. Then we have angles in between, such as 30 degrees, 45 degrees, 60 degrees. This is the first quadrant, and you should be able to tell. For example, if you're interested in 150 degrees, the reference arc is 30 degrees. And that's the concept. When I know that sine of 30 is 1/2 as an example, then the sine of 150 has the same value, but positive or negative depends on the quadrant. In the second quadrant, sine is positive. Determine the length of arc of a circle and area of a sector formed by the central angle theta if theta is 1/2 radian and r is 10 meters. Well, let's discuss the concept. The central angle theta this is the arc that is covered by this angle. This is the arc length. S, it's not a straight line, that's why they call it arc length. S equals r theta. If you go with this area, it's a portion of the total area, and it's half of r squared theta. So these are the formulas we should know. So S equals r theta. In this case, r is 10, theta is half of radian, and it should be in radians. If it's in degrees, you change it accordingly. So that becomes 5, and the units would be the units of the radius, 5 meters. Area is 1/2 r squared theta. So 1/2 r squared theta, which is 1/2. And so this is 100. This is 4. 100 divided by 4. 25 units of the area is meters squared. Now, what happens in this case, we use the same formula. However, this must be in radians and it's not. You change it and 60 degrees is pi over 3. It's one of those common arcs. It helps if you know that, okay? So pi over 3, 60 degrees pi over 3. At 30 degrees is pi over 6. 45 degrees is pi over 4. So S equals R theta, so 5 times this number, which makes it precisely 5 pi over 3, the same unit as the radius in feet. Roughly, they most likely will ask you how many decimals, then you do it accordingly. Area, we do the same thing, half of R squared theta, and of course, theta is pi over 3. Clearly, this is 25 pi, and the bottom is 6. Again, this is an exact answer, everybody. Yeah, get to the habit of always writing the exact answer and then rough estimate depending on how many decimals, 13.090 square feet. That would be the answer. The radius of each wheel of a car is 15 inches. From here to here, 15 inches. If the wheels are turning at a rate of 3 RPS, revolutions per second, RPS, revolution per second. How many revolutions? 3. So they go a complete revolution. How many times? 3 times per second, each second. How fast is the car moving? Express your answer in inches per second and in miles per hour. So we are going to add a couple of formulas. Omega is called angular velocity. Is theta over t. Or 2 pi times RPM. V is the linear velocity, is distance over t r omega, S equals r theta. And so I'm going to write linear velocity, V, is total distance over total time. Okay, so the total distance that is covered along the curve is S over total time. That is called linear velocity. Now, as it covers the arc, it also covers some sort of an angle that's called omega, angular velocity. The angle divided by time, or theta over t, would be 2 pi RPM. Okay. So what is the angular velocity? 2 pi times revolutions per minute, or revolutions per second, or revolution per hour. This is the unit of time, whatever the unit of time. It happened to be SRPS. So 2 pi times RPS in this case. And by the way, class, the velocity is S over t. Remember, we said S is R theta. You can separate the R from theta over t, and it gives the relationship between linear velocity V and angular velocity omega. V equals R omega, everybody. So R is 15 inches. Omega is 3 revolutions per second. How fast is the car moving? We are looking for the linear velocity. And so we start with omega. Finding omega is 2 pi times RPS. So 2 pi times 3, and that means 6 pi radians per second. That's angular velocity. What is the linear velocity? V equals R omega. So V equals R omega. R is 15 times omega. So that gives us 15 times this number we just found, 6 pi, which makes it 90 pi. Now, radians per second, because of R being 15 inches, becomes inches per second. So the answer is 90 pi inches per second. This is exact. Again, a rough estimate, they will tell you how many decimals, okay? So I want to make sure that you understand that this is an approximation, and you want to, in this case, definitely they want the approximation, you want to pay attention to number of units, number of decimals they're asking, okay? So that is important. So we have 90 pi inches per second, and we want to take it to miles per hour. They want miles per hour. Well, we know 1 mile is 5,280. And I want to remind you, when it comes to unit conversion class, if you write 1 mile over 5,280 feet, this is 1. Or if you write 5,280 feet over 1 mile, this is also 1. This is called unit conversion. Now the question is, which one do you use and why? You look at the result, you want miles per hour, so you want the miles to be at top. Okay? So again, you can use any of it, but you want to use the one that gives you the result you want. When I say you can use any of them, both of them are equal to 1, unit conversion, unit conversion. So I'm going to erase my work first. So I want to go from inches to miles, and I want to go from the seconds to hours. So from inches, we know 1 mile is 5,280 feet. And 1 foot, 12 inches. So we want to put 1 foot over 12 inches, 1 miles over 5,280 feet. And the timing, remember, 1 hour is 60 minutes. 1 minute is 60 seconds. Therefore, 1 hour is 3,600 seconds. Now, notice what happens as far as the units are concerned. This one cancels out this one. Okay. This one, let me use a different. This one cancels out this one. Okay. This one cancels out this one. So as far as the units are concerned, you have miles per hour. As far as the numbers, the numerator is 90 pi times 1 times 1 times 3,600. The denominator is 12 times 5,280 times 1. You put that into a calculator, and it results in 16.1 miles per hour, which means If the wheels are turning at 3 revolutions per second, they give us 16.1 miles per hour as far as the speed, linear speed is concerned. Okay. Again, that's pretty straightforward. We are going to move on to the next question. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find the angle theta this arc covers or subtends. So obviously what's given is S equals 50 inches. What's given is R, radius is 6. So first we write that, and when it comes to that, remember, we are interested in finding theta, right? And so S equals R theta. If S equals R theta, and theta must be S over R. So then we replace the S. That's why when you read, it's important to write the given. When you write the given, all you have to do, follow that 50 divided by 6. That's 25 thirds, precisely 25 thirds radians. And again, if they want an approximation, they ask you. We want to find the area of a sector, this area that is covered by the central angle, so half of R squared theta. Replace the R with number 6, and theta, we just found it to be 25 thirds. Remember, it has to be in radians, and it is. Notice this is 36, and cancels this one. And this is 6 times 25, 150 units of area, because this is in inches, 150 inch squared. So from the units, you can get the proper units as well. Find the linear velocity of a cylinder with a 2-foot radius that is spinning at 40 RPM. So let's write the given. R is 2 feet. It's spinning at 40 RPM. Omega is 40 RPM. We want the linear velocity. So we know V is R omega, but before that, omega is 2 pi R PM. Okay. RPM, remember, revolutions per minute, because this is RPM. So you have to change it. So 2 pi times 40. 2 pi times RPM or RPS or RPH, depending on the unit. Could be revolutions per minute, revolutions per second. This last one, in this case, is minutes. Could be seconds, could be hours. So 2 pi times 40 gives us 80 pi radians per minute. And that's what we want. We want it in radians. Radians per minute, everybody. So V equals R omega. That means 2 the radius times 80 pi the omega And that's precisely 160 pi. And you can put it into a calculator, but 160 pi feet per minute. Units of R now in feet per minute. So 160 pi, which is about 502.65 feet per minute. So pretty straightforward, everybody. Find the exact value of each of the remaining trigonometric functions of theta, given that tan theta is minus square root of 3 over 3 and sine theta is positive. The reason they give us those two information so we can figure out the quadrant, because we need to know what is positive, what is negative, and what in which quadrant, okay? So first I want to remind you of this concept that was mentioned, that this is a unit circle, x squared plus y squared equals 1, centered at 0, 0, with the radius 1. If you choose a different radius, becomes x squared plus y squared equals r squared. So if we go with r squared, any point P which has coordinates x comma y or a comma b, sine is y over r. Otherwise, it's y over 1, which becomes y. In the case of a unit circle, sine becomes y over 1. In the case of a radius, could be anything, y over r or b over r. Cosine is x over r. As long as we know these two, everybody, the rest are easy to come up with. Tangent is sine over cosine, so it becomes y over x or b over a. Cotangent is the reciprocal of tangent, x over y. Cosecant is 1 over sine, so the reciprocal of that, and secant is the reciprocal of cosine. The next thing I want to add is the information from various quadrants. So as I mentioned, this is quadrant 1, 2, 3, 4. In the first quadrant, all trigonometric functions are positive: sine, cosine, and tangent. By the way, the reason we write the three of them, because the other three are the reciprocals, they follow the same sign. When we go to the second quadrant, sine is the only thing that is positive. The rest of them are negative. So if sine is positive and cosecant is the reciprocal of that, so is cosecant. When we go to the third quadrant, sine and cosine are negative. Tangent is positive, so is cotangent. When we go with the fourth quadrant, cosine is positive, and therefore secant. So remember, one easy way to handle this, if you have a unit circle, cosine corresponds to x, okay? So x is the same as cosine, y is the same as sine. If we remember that, then of course in the first quadrant, x and y are positive. In the second quadrant, okay, x is negative. So that means cosine becomes negative. And so in this one, x and y are both negative, okay? In this one, y is negative. So just go with x and y. X corresponds to cosine, y corresponds to sine. So that makes it almost impossible to forget. So Tan of theta is a given and it's negative. So if tan is negative, class, then it has to be either this one or this one. But which one? Well, sine is positive in this one. Has to be quadrant 2. And since this is a common arc, theta becomes 5 pi over 6. So let me quickly write something for you, and that is pi over 6. The theta is pi over 6. Sine of pi over 6 is 1/2. Cosine is square root of 3 over 2. Tangent of pi over 6 square root of 3 over 3. The rest of them I'm not going to write, okay? They become the reciprocal, okay? Cosecant becomes 2 over 1 or 2. A secant becomes 2 over square root of 3, and this cotangent becomes 3 over square root of 3 or just square root of 3. So if that is the case, we recognize this one, okay, almost the same as pi over 6, but this is negative, okay, and it's in the second quadrant. So right away, we notice that pi over 6 for this case is the reference arc. So in the second quadrant, you subtract this from pi and you get 5 pi over 6. And it's a common arc, you should know the answer, but just in case, okay, if you didn't know it, pi over 6 and so forth, because you have these two pieces of information, you can figure all of them, and we're going to go over that. So let me erase my work. So we say tangent is y over x. And remember, in the second quadrant, y is still positive, x is negative. That's why you can put this negative sign in front of the numerator or the denominator, makes no difference. You get the same answer. So it must be x. And now put it into this. For example, if you want to go with sine theta is y over r. So all you have to do, y over r. Now, what is r? X squared plus y squared equals r squared. So square this one, add them up. This gives you 3 squared, the same as 9. Let me just, negative or positive makes no difference. This is 9. This is 3, so it's 12. So r is square root of 12. As you know, 12 is 4 times 3, so it's 2 square root of 3. Now that you have all of them, that means you have x, you have y, and you have r, just plug in. Sine would be y over r, which is square root of 3 over r, and these two cancel each other. You get 1/2, and you can figure out the rest. I'm going to leave them for you to figure out if sine is 1/2. Cosine is x minus 3 over r, 2 square root of 3, and then rationalize it. And the rest of them are the reciprocals. So again, we have the tangent. I showed you how to find x and y, how to find sine. You can figure out the rest just following those formulas. Of course, it can be done with identities as well. So find the exact value of each of the remaining trigonometry where secant is given as 2 and sine is negative. Well, secant is 1 over cosine theta, which means you know cosine theta to be 1/2. So if Secant is positive, so it's cosine. And sine is negative, it must be quadrant 4. So secant is 1 over cosine or 2 is positive. Sine is negative, that results in quadrant 4. And cosine is 1/2. Of course, the reciprocal. Now, we can use the same methodology as the previous one. I'm not going to do that, but that would be, this is x over r. So you would say x is 1, r is 2. You can find y using x squared plus y squared equals r squared, and follow the same methodology as before. Today, for this one, I want to do sine squared plus cosine squared equals 1. In other words, one of those Pythagorean identities. Okay. So this is one of the Pythagorean identities. So sine squared plus cosine is 1/2 squared 1/4. We're going to subtract 1/4. We get 3/4. And sine becomes plus minus the square root of 3/4. And so you have to choose positive or negative based on the quadrant. Obviously, sine, it says negative. So you have to choose the negative. So minus square root of 3 over 4. Square root of 3 remains 4, comes out as 2 because it's in the quadrant. Now, the rest of them just follows, okay? Cosecant is 1 over sine, tangent is sine over cosine, cotangent is 1 over tangent. So cosecant is 1 over sine, so the reciprocal of that. Again, the answer is minus 2 over square root of 3. You can rationalize it by multiplying by square root of 3 over square root of 3. You get this one. So we have a cosine and secant. We have sine and cosecant. Tangent is sine over cosine. So sine is this number minus square root of 3 over 2. Cosine is this number, and we can drop the common denominator of 2. So minus square root of 3. And cotangent is the reciprocal of this number. 1 over minus square root of 3, which is minus square root of 3 over 3. Plus, this is if you rationalize. In other words, multiply by square root of 3 over square root of 3, you can see the answer. So the purpose of this question versus the other one to show you that you could go either way. You can go with identities or the unit circle or just a circle in general. And let me erase my work so you can see this. So I then write everything here because I don't want to miss anything. I highly recommend you always, whenever you're done, write all the answers to make sure you haven't missed anything. Which method will you use? It depends on whether they ask you a specific method or not. If they don't, either way is fine. We want to simplify secant of power 4 times cotangent of power 4, and we are remembering those identities. Therefore, secant we are going to write as 1 over a cosine of power 4. The reason we do, because power 4 is one of the common arcs, and cosine is square root of 2 over 2. Cotangent is 1. So it's 2 over square root of 2, which makes it square root of 2. All right, we want to add two fractions. We take LCD, everybody, which is sine theta, cosine theta. And when we do that, then this times this. So sine theta plus cosine theta times this minus this one times this. What do we get here? When we multiply these two, we get sine theta cosine theta plus cosine squared theta. When we multiply this one, we get sine theta times cosine theta and then negative sign. This one we get minus sine squared and this one plus. So what happens is that these two cancel each other. We have cosine squared plus sine squared in the numerator, and that is equal to 1. So 1 over sine theta cosine theta. You can make up two fractions, 1 over sine theta times 1 over cosine theta. 1 over sine theta is cosecant theta, and 1 over cosine theta is secant theta. So we are using identities to simplify. They are very simple, everybody. Sine squared theta plus cotangent squared theta plus cosine squared theta. You don't have to move them, but just in case, if you move them next to that, you notice that these two add up to 1. So we get 1 plus cotangent squared, which is cosecant squared. So what do we have here? We have Pythagorean identities. There are 3 of them, everybody. First, sine squared plus cosine squared equals 1. If you divide both sides by sine squared, you get the last one, because 1 cosine over sine is cotangent squared and cosecant squared. If you divide by cosine squared, you get the second one. 1 plus tan squared equals secant squared. Those are Pythagorean identities we should be comfortable with. Cosine of power 6 times secant of 13 power 6. And the first thing I want you to know that this is 12 power 6 plus power 6. And 12 power 6 means 2 pi, reminding you of the fact all trigonometric functions are periodic. So we can take out 2 pi or 12 power 6. So it becomes cosine of power 6 times secant of power 6. As you know, that secant is 1 over cosine. So divide by cosine power 6 or times 1 over cosine. They cancel each other. They give us 1. So the final answer is 1. All right, what about this one? Well, it's fairly simple. Cotangent theta doesn't change because the period for tangent and cotangent is pi. By the way, I add pi or I subtract pi. I add 2 pi here or I subtract, makes no difference because it's really 2k pi. And so this one is cotangent, this one is cotangent also. So you have 3 of them, and the final answer is 3 cotangent theta.